The atmospheric sensors began their polite apocalyptic screaming at approximately 1400 hours local time, which gave the expedition precisely 47 minutes to realize they were catastrophically unprepared for what was coming. The research outpost on Keld 9, a planet whose primary appeal was its boringly predictable weather patterns, had been operating for 6 months without incident. The mixed species team had settled into the comfortable rhythm of scientific routine, sample collection, data analysis, meal schedules, and the occasional interdepartmental complaint about equipment allocation. The 3 humans, Harlan, Vess, and Dimitri, occupied the atmospheric analysis division alongside their colleagues from 2 other species who had collectively concluded that Keld 9 represented minimal survival challenges and maximum research opportunities. This assessment aged poorly. The Kesh, tall beings whose segmented carapaces gave them the appearance of ambulatory architectural diagrams, preferred controlled environments, and had designed most of the habitat modules with temperature regulation that bordered on obsessive. Their representative scientist, Torvik, had published 14 papers on environmental predictability as a foundation for successful colonial expansion. The Rill, amphibious and vaguely frog-adjacent in their general aesthetic, had joined the expedition specifically because Keld 9's humidity levels matched their biological comfort zone. They communicated through a combination of vocal clicks and skin pattern modulation that the translation software rendered into slightly formal standard, with an inexplicable tendency toward parliamentary procedure. The humans had joined because the pay was acceptable and the isolation appealed to people who'd grown tired of crowds. When the sensor arrays detected the atmospheric anomaly, Torvik immediately convened a meeting to discuss interpretation protocols. The Rill senior researcher, whose name translated as Committee Member for Aquatic Transition Studies, but who answered to Click, began formulating a report structure. Harlan, who'd been monitoring the data feed while eating what the food dispensary optimistically labeled a sandwich, stood up and walked to the supply lockers. Vess glanced at the pressure readings, made a sound that wasn't quite a word, and started pulling emergency kits from storage. Dimitri studied the velocity projections for approximately 8 seconds before heading outside to check the physical anchoring systems on the habitat modules. The blizzard arrived 6 minutes ahead of the sensor's worst-case timeline, which suggested the sensors had been either conservative or malfunctioning. Neither possibility mattered much at that point. The wind carried crystalline precipitation that wasn't quite snow. The local atmospheric chemistry produced something closer to frozen shards that reflected light in aesthetically pleasing ways, while also shredding anything organic with the efficiency of automated sanding equipment. The temperature dropped 40 degrees in the first 10 minutes. Habitat modules designed for mild climate variation began registering hull stress warnings. The power grid, which relied on solar collection and atmospheric processing, failed 17 minutes into the storm when ice accumulation blocked the intake valves and shattered 2 collection panels. Inside the main module, the expedition members experienced what disaster psychologists call acute normalcy disruption, which is professional terminology for panic dressed in academic language. The Kesh began calculating survival probabilities aloud, which helped nobody. The Rill huddled together, their skin patterns flickering through colors that indicated distress in a language everyone understood regardless of translation software. Equipment that had functioned flawlessly for 6 months chose this moment to demonstrate spectacular failure modes. The lighting died. Emergency backup systems provided dim illumination that made everything look like a stage set for tragic theater. Harlan found Dimitri checking the structural integrity reports on a handheld display that was already showing frost accumulation on its screen. "We've got maybe 4 hours before the main module fails," he said, his voice carrying no particular emotion about this timeline. The emergency shelters are rated for this temperature, but not this wind pressure. They'll collapse. Inventory? Harlan asked. Scattered across 6 storage points. Some will be buried or destroyed. We'll know what we have when we can get outside. Vess appeared from the equipment bay carrying thermal wrapping and what looked like half the medical supplies. The RIL are shutting down. Their biology can't handle this cold and the humidity drop. Quiche are slow but functional. We need heat and shelter immediately, not in 4 hours. The storm continued for 30 hours, which felt considerably longer from inside a gradually disintegrating habitat module. The expedition members huddled in the central corridor, the most structurally reinforced section, wrapped in every insulating material they could find. The wind outside produced sounds that ranged from low roaring to high-pitched screaming, occasionally punctuated by the crash of equipment being torn from its moorings and flung into the darkness. The humans took turns staying awake to monitor conditions, though there wasn't much monitoring to be done beyond noting that yes, everything was still terrible, and no, it hadn't improved since the last check. When the storm finally exhausted itself, it left behind a landscape that resembled the aftermath of a war between weather systems and infrastructure, with weather claiming decisive victory. The main habitat module had partially collapsed, its walls buckled inward and covered in a thick layer of the crystalline ice snow that had achieved structural integration with the metal. The emergency shelters existed only as scattered fragments of high-tech fabric frozen into artistic shapes. The communication array was simply gone, not damaged or broken, but absent, presumably relocated to somewhere downwind and no longer relevant to the expedition's immediate concerns. Equipment lay scattered across the terrain, buried under irregular drifts or protruding at angles that suggested violent displacement. The expedition members emerged into dim daylight. Keldmine's sun filtered through atmospheric disturbance that would take days to clear, and conducted their individual assessments. The quiche moved slowly, their biology struggling with temperatures that their comfort zone had never anticipated encountering. They gathered near what remained of the main module, clicking their mandibles in distress patterns. The RIL were worse off. Their skin had taken on a dull, grayish tone that indicated severe physiological stress. They could barely move, their usual fluid grace replaced by stiff, painful-looking attempts at locomotion. Harlan, Vess, and Dmitri stood in a rough triangle, each scanning different sections of the wreckage with the systematic attention of people conducting triage. They didn't speak immediately. The assessment required observation more than discussion. Harlan noted the terrain features, a rocky outcropping approximately 200 meters northeast that might provide wind shelter. Vess was already walking toward the scattered equipment, beginning the mental inventory of what might be salvaged versus what had become expensive debris. Dmitri studied the expedition members themselves, categorizing injuries and functional limitations with the detached efficiency of someone who understood that sentiment wouldn't improve anyone's survival probability. "Shelter first," Harlan said finally. "That depression by the rocks. We dig in, use the terrain." Dmitri nodded. "I'll start." "Vess, we need insulation material, anything that traps air." "Already looking," Vess replied, which was accurate. She'd begun pulling sections of thermal wrapping from the wreckage, testing their integrity with quick flexes before adding them to a growing pile. Torvik approached, his tall frame listing slightly to one side, possible structural damage to his lower segments. "We should establish a hierarchy for decision-making," he said. "Organize a planning committee to determine optimal resource allocation and survival strategy." Harlan glanced at him while pulling on insulated gloves she'd retrieved from somewhere. "That's a good idea. You should definitely do that. We're going to dig a hole." This was not the response Torvik expected. The Kesh operated on consensus-based hierarchical frameworks with clearly defined decision-making protocols. Humans, he was discovering, operated on something closer to organized improvisation, with a tendency toward immediate physical action. He watched, confused, as Dmitri walked to the rocky outcropping and began examining the terrain depression with the focus of someone evaluating real estate. Finding the assessment satisfactory, Dmitri picked up a broken equipment panel. It had once been part of a sensor array, and began using it to dig into the accumulated ice snow. Not frantically, not dramatically, just methodically scooping and scraping, creating a widening depression in the ground. Vess had begun sorting salvaged materials into categories that made sense to her: flexible insulators, rigid structural pieces, seal-capable fragments, and a miscellaneous pile of items whose utility remained theoretical. She worked quickly, but without panic, her hands moving with the practiced efficiency of someone who'd done equipment assessment in suboptimal conditions before. The pile grew. Other expedition members watched, uncertain whether to help or wait for instructions that weren't coming. Click, the real researcher, made their way toward Harlan with obvious difficulty. Their skin patterns flickered weakly. "We require formal survival protocol activation," they said, the translation software adding a slight echo to their distress. "Emergency measures, leadership designation." Harlan was testing the structural integrity of a collapsed shelter frame. "Leadership's whoever's working. Right now that's us. You need immediate shelter and warmth. Can you help carry insulation material?" "That is not the proper procedure." "No," Harlan agreed. "Proper procedure is about 200 meters that way, frozen solid. We're doing improper procedure. Can you carry things, or do you need to conserve energy?" Click's skin patterns shifted to something that might have been resignation or possibly agreement. "I can assist with light materials." "Good. Vess has a pile that needs moving to where Dimitri's digging. Anything you can manage helps." The work began to organize itself through demonstration rather than direction. Dimitri dug, so others started helping dig. The Kesh, who retained mobility, used their stronger limbs to move larger chunks of frozen material. Vess sorted, so equipment naturally migrated to her staging area, where expedition members could see what was available. Harlan moved between tasks, answering questions by showing rather than explaining, her actions creating a template that others followed because following felt better than standing in the freezing wind trying to establish proper protocol. The shelter took shape over the next several hours, growing from a simple depression into something approaching deliberate architecture. The humans worked with the terrain rather than against it. The rocky outcropping provided natural wind protection on two sides, reducing the digging required. They used the broken equipment panels as structural reinforcement, creating a framework that could support a roof. The roof itself became a collaborative engineering project, layered thermal wrapping interspersed with rigid panels, creating air pockets that would trap heat while supporting the weight of any ice accumulation. Harlan explained the physics while installing insulation, speaking to whoever was nearby and happened to be listening. "Dead airspace holds heat better than solid material. You want layers with gaps. Each gap is a thermal barrier. Body heat warms the air. Insulation traps it. Temperature rises. Basic principle." "This is primitive construction," Torvik observed, though he was helping secure a panel as he said it. "Extremely primitive," Harlan agreed. "Humans have been digging holes for shelter since before we had language. Probably our third or fourth best skill, after walking long distances and explaining why our plans are definitely going to work this time." Vess had discovered that some of the equipment batteries retained charge, not full charge, but enough to potentially function if warmed gradually and used sparingly. She'd rigged a connection between 3 batteries and a heating element salvaged from a food preparation unit, creating a power system that produced a small but steady amount of warmth. It wasn't enough to heat the entire shelter, but positioned correctly it could maintain a survivable temperature in the enclosed space. The work was unglamorous in the extreme. Digging, packing, testing, adjusting, repacking when the first attempt proved inadequate. The humans moved with practiced efficiency that looked unremarkable because competence often does. They didn't perform heroic feats of engineering or demonstrate superior strength. They just worked steadily, solving small problems in sequence, building toward functionality rather than perfection. Why didn't we plan this properly before beginning construction? Torvik asked at one point, watching Dmitri adjust the roof angle for the 3rd time. Dmitri paused in his work, considering the question with apparent seriousness. We're just planning by doing. Try something, see if it works, adjust if it doesn't. Planning in committee means everyone freezes while we discuss optimal shelter geometry. But this approach lacks systematic methodology. It has systematic methodology. Vess called from where she was sealing gaps in the wall. The system is do something, notice the result, do the next thing. Very systematic. We've been using it for thousands of years. The shelter became functional as the day's limited light began fading. It was cramped, 8 expedition members in a space designed through necessity rather than comfort, but it was enclosed, insulated, and demonstrably warmer than the outside environment. The temperature inside registered barely above freezing, which represented a significant improvement over the negative temperatures outside. Body heat from 8 individuals in close proximity began to accumulate, the thermal mass of living beings doing what the insulation trapped. Harlan established a rotation schedule for monitoring the shelter's integrity, someone awake at all times to check for ice accumulation, structural stress, or ventilation problems. The humans took the first shifts, demonstrating what needed watching and why. The pattern of breathing that indicated carbon dioxide buildup. The sound of wind that suggested a seal was failing. The feel of the walls that showed where heat was escaping and insulation needed reinforcement. With shelter established and marginally functional, Harlan turned her attention to fire, or the closest equivalent possible, in Keld-9's atmospheric composition. The planet's air wouldn't support combustion in the traditional Earth sense. Oxygen levels were adequate for breathing, but insufficient for sustained burning. However, chemical heat remained possible through catalytic reactions that didn't require flame. The expedition's laboratory equipment contained various reactive compounds. The destroyed sensor arrays held catalytic chambers designed for atmospheric analysis. These could be repurposed. She worked methodically, combining fuel cells with oxidizing agents in improvised reaction chambers, testing small quantities first to observe the results. Most combinations produced insufficient heat or consumed resources too quickly to be sustainable. The 7th attempt generated a steady exothermic reaction that produced warmth without visible flame, not impressive to observe, but functionally excellent. The heat output was modest but consistent, and the fuel efficiency suggested the available materials could maintain the reaction for several days. The aliens watched this experimental process with expressions, or their equivalent, of mixed fascination and bewilderment. To them, Harlan appeared to be randomly combining chemicals until something useful happened, which was not entirely inaccurate as a description of experimental methodology. She explained her reasoning while working, more thinking aloud than teaching, but the expedition members absorbed the lesson regardless. "It's just high school chemistry," she said, adjusting the catalyst mixture. "Exothermic reactions release energy as heat. Find the right combination, control the reaction rate, maintain it at a useful level. Humans have been making fire in terrible conditions for a very long time. We've gotten pretty good at it," Vess added, without looking up from the battery monitoring she was conducting. "Making fire is one of humanity's core competencies, right up there with walking, talking, and finding new ways to complicate simple situations." The catalytic heat source became the shelter's centerpiece, literally and functionally. Positioned in the middle of the space, it raised the ambient temperature to almost comfortable levels and provided a psychological benefit that Harlan suspected was more valuable than the physical warmth. Fire, or its chemical equivalent, represented control over the environment. It transformed a hole in the ground into something approaching a home, however temporary. The heat source also enabled water production. Keld-9's ice snow could be melted into liquid water, though it required slow, careful heating to avoid damaging the catalytic system. Harlan established a rotation for ice collection and melting, creating a schedule that gave everyone tasks and ensured a steady water supply. The work provided purpose, which prevented the idle desperation that could undermine group cohesion. Food became the next systematic concern. The expedition's supplies were scattered across the devastated camp, some buried under ice, some destroyed by the storm's violence, some potentially intact but frozen into blocks that required careful thawing. The humans began search operations using a grid pattern, marking searched areas with broken equipment to prevent duplicate efforts and ensure comprehensive coverage. Dmitri demonstrated the marking system to the other expedition members. "We search in overlapping sections, mark what we've covered. Collect anything that might be food, fuel, or useful equipment. Bring it back to the staging area. Vess catalogs it. We assess what's usable." The cache could survive extended periods without food. Their biology included energy storage systems that made them remarkably resilient to fasting. The Rill lacked this capability. Their metabolism required regular nutrition, and the cold was accelerating their energy consumption as their bodies struggled to maintain core temperature. They were weakening visibly, their movements becoming more labored, their communication patterns slowing and becoming sporadic. The humans found frozen ration packs half buried in an ice drift. They discovered a storage container that had remained sealed and intact, its contents frozen but undamaged. They located equipment that contained emergency nutrition reserves, high-calorie compounds designed for exactly this scenario. Each discovery was brought back, assessed and added to the inventory that Vess maintained with meticulous attention to detail. Thawing the food became a careful process. Too much heat too quickly would destroy nutritional content or create bacterial growth risks. Too little heat meant frozen rations that nobody could consume. Dmitri showed the others how to use body heat and the catalytic warmer in combination. Hold the frozen package close to the body for gradual warming, then finish thawing near the heat source under controlled conditions. Slow, inefficient but effective, Vess created a rationing system based on biological necessity rather than rank or species politics. The Rill received priority because their physiology demanded it. The cache received minimal rations because they could function without. The humans took moderate portions, enough to maintain capability without depleting resources others needed more urgently. This distribution surprised the Rill, whose cultural frameworks included strict hierarchical resource allocation. The concept of need-based distribution seemed almost radical to them. Click raised this point during one of the meal distributions, their skin patterns showing confusion. "Why do we receive preferential nutrition access? This violates standard expedition protocols." Harlan handed them a thawed ration pack. "Because you'll die without it and we won't. Keeping everyone alive keeps everyone useful." Dead crew members don't help with shelter maintenance or equipment salvage. This is pragmatic, extremely pragmatic. Also the right thing to do, but mostly pragmatic. The feeding schedule became ritual, something dependable in the ongoing uncertainty. Twice daily, the expedition members gathered around the catalytic heat source to receive their rations and share the minimal water supply. The repetition created structure. Structure created calm. Calm enabled thinking beyond immediate survival toward medium-term planning. Days accumulated in the shelter with a sameness that made time feel theoretical. The humans established routines that organized existence into manageable segments, wake periods with assigned monitors, work shifts for equipment salvage and shelter maintenance, rest periods with mandatory sleep to prevent exhaustion-based errors, meal times that provided social gathering opportunities. The schedule wasn't elaborate, but it transformed survival from a crisis into a sustainable system. They taught the alien expedition members to read the environment through observation rather than instruments. Harlan demonstrated how wind sounds indicated pressure changes. A rising pitch meant increasing velocity, which meant potential structural stress on the shelter. Vess showed them ice accumulation patterns and what they revealed about heat loss points where insulation needed reinforcement. Dimitri explained biological rhythm monitoring, how to estimate time passage by tracking sleep cycles and hunger patterns when no chronometers functioned. Torvik commented, during one of these informal teaching sessions, that human survival methodology seemed to involve excessive watching and minimal action. Harlan, who was checking wall seals while he spoke, nodded agreement. Most of survival is just noticing things and not panicking about them. Action comes after observation. Rush into action without noticing what's actually happening, you make everything worse. This seems passive. It's extremely active observation. We're constantly monitoring, assessing, adjusting. We just do it quietly without announcing every decision. The humans created structure from observation, not imposed hierarchy but emergent order based on what worked. When they noticed condensation accumulating in one section of the shelter, they adjusted the ventilation configuration. When ice patterns showed thermal weaknesses, they added insulation to those specific areas. When the sleep rotation left certain people exhausted, they modified the schedule. Nothing revolutionary, just attentive adaptation performed continuously. The alien crew members began adopting these observation practices, learning to see their environment as a source of information rather than a hostile mystery. The Kesh, with their analytical tendencies, took to pattern recognition quickly. The Rill learned to read atmospheric conditions through moisture sensing that their biology naturally supported. Everyone became slightly better at noticing what mattered and adjusting accordingly. On the 8th day, a rescue ship arrived, delayed by the same storm system that had devastated the camp but finally able to land once the atmospheric disturbance cleared. The ship's sensors located the expedition members through their emergency beacon, which Dimitri had repaired on day 5 using scavenged components, and what Vess described as unreasonable optimism about making electronics work in freezing temperatures. The rescue team found the mixed-species crew alive in their improvised shelter, organized and functioning with a calm that seemed incongruous given the surrounding devastation. The team leader, a human woman named Kowalski who'd spent 20 years in emergency retrieval operations, surveyed the dugout shelter, the catalytic heat source, the organized supply staging, and the crew members who looked exhausted but coherent. "How did you manage this?" she asked Harlan directly. recognizing a certain practical competence in how the shelter was organized. Harlan shrugged, the gesture conveying both modesty and fatigue. We just did what needed doing. Shelter, heat, food, water, standard priorities. Kowalski studied the shelter's construction more carefully, noting the layered insulation technique, the ventilation system, the efficient use of salvaged materials. This is good work. Better than good. You kept everyone alive in conditions that should have killed half your crew. Everyone stayed alive because everyone worked. Vess interjected. Wasn't just us. The alien crew members had different perspectives to offer. Torvik, who had regained most of his mobility and typical analytical demeanor, provided a detailed account to the rescue team's documentation specialist. He described the humans' immediate response to the shelter crisis, their methodical construction approach, their patient teaching of survival techniques, and their resource distribution system that prioritized biological need over social hierarchy. I have fundamentally recalibrated my understanding of human persistence, Torvik said, his translator rendering the statement with unusual emphasis. They do not survive through superior planning or greater strength. They survive through refusing to stop identifying options and implementing solutions, even when the solutions are unglamorous and the options are severely limited. Click offered similar observations, their skin patterns displaying colors associated with gratitude and respect in real cultural communication. The humans fed us when resources were scarce. They maintained warmth. They created patterns and structure when chaos dominated. This behavior contradicts our previous models of survival priority systems. Dmitri, overhearing this, responded while gathering his minimal personal effects for evacuation. Survival priority is keeping everyone functional. Can't do that if half the crew is dead. Pretty simple calculation. The evacuation proceeded with efficient routine. The rescue team had performed this operation many times and moved the expedition members to the ship with practiced speed. Medical personnel assessed everyone, treating the RIL for cold stress complications and the cage for structural damage to their carapaces. The humans showed signs of exhaustion and minor frostbite, but nothing requiring intensive intervention. As they prepared for departure, Vess looked back at the shelter through the ship's viewport. The dugout remained intact, its construction solid enough to withstand conditions that had destroyed engineered habitats. That'll probably last years if the wind doesn't take it, she observed to nobody in particular. Harlan smiled slightly. Humans build things that outlast the crisis that required them. Not from optimism. Just habit. Aboard the rescue ship, the expedition members recovered in proper medical facilities with regulated temperature and adequate nutrition. The humans submitted incident reports with characteristic understatement, focusing on technical details of shelter construction, resource management, and survival timeline. Their documentation read like engineering specifications rather than survival narratives, heavy on measurements and procedural descriptions, light on emotional content or dramatic interpretation. The Cage and RIL crew members wrote more elaborate accounts, describing the experience as transformative in their understanding of human capabilities. Their reports included extensive analysis of human decision-making frameworks, observational methodology, and social cooperation under stress conditions. Several mentioned planning to revise their species' survival training protocols based on techniques observed during the crisis. Torvik sought out Harlan in the ship's common area several days into the return journey. She was reading something on a data pad and drinking coffee that the ship's dispensary produced with adequate if uninspired competence. "I have a question," Torvik said, "if you have time for inquiry." Harlan gestured to the empty seat across from her. "Sure. What's the question?" "Do humans ever panic?" experience fear-based paralysis. The accounts I've studied suggest this is common among sentient species during crisis situations. Harlan laughed, the sound genuine and slightly tired. Constantly, internally, absolute terror most of the time. This answer clearly confused Torvik. But you demonstrated no such paralysis. Your actions were efficient and purposeful, because there's usually something that needs doing regardless of the terror, and doing something feels better than sitting still being terrified. So you dig the hole, or light the fire, or feed the people who are starving. The panic's still there. You just work around it. This seems difficult. It really is, Harlan agreed. Gets slightly easier with practice. Slightly. The conversation drifted to other topics. Torvik's planned research on atmospheric prediction models, Harlan's intention to take a long vacation somewhere warm, but the underlying question remained present in the subtext. How did humans function when everything suggested they shouldn't? How did they persist through conditions that broke other species? The answer, Harlan suspected, wasn't particularly profound. Humans survived because they'd been surviving for a very long time, through ice ages and droughts and countless environmental catastrophes. They developed not superior intelligence or greater strength, but rather a stubborn habit of noticing what might help and trying it even when success seemed improbable. They built shelters in terrible conditions, made fire from inadequate materials, and fed each other when resources were scarce, not from nobility or heroism, but from the deeply ingrained knowledge that everyone surviving improved everyone's odds. The blizzard had devoured their camp entirely, consuming the habitat modules and emergency shelters and communication equipment with indiscriminate thoroughness. But it couldn't quite digest the humans, who proved persistently indigestible through nothing more spectacular than attention, routine, and the unglamorous work of refusing to quit noticing what might help. They dug a hole, lit a fire, and fed the frozen crew not because these actions were dramatic or heroic, but because these were the things that needed doing, and humans had become very good at doing necessary things even when the circumstances suggested they shouldn't bother trying.